Hello, welcome to our first video on sequences. This is going to be a short unit, only 3 lessons, so we won't be having a full test, but just a quiz in a couple weeks. The objective for today is I can write a recursive formula for an arithmetic or geometric sequence. Now that might sound like a lot of stuff you've never heard of before, but I promise you're going to like this. First of all, what is a sequence? Remember back in elementary school when you were supposed to find a pattern in the numbers and then tell the next 3 numbers in the pattern? That's basically a sequence. So if we look at this first list of numbers, we got 5, 10, 15, and 20. That is a sequence. It has 3 dots that show that it keeps going out forever and ever and ever following the same pattern. So your job with a sequence is to first figure out what is the pattern. And you can probably already tell that we're adding 5 every time. So if I wanted to find the next 3 numbers in the sequence, then I would add 5, and so I would get 25, 30, and 35. That wasn't so hard. That's feeling pretty good so far, right? Let's look at another sequence. This time it goes 4, 12, 36, 108. So if you were asked to find the next 3 terms in that sequence, let's look at what the pattern might be. At first you might think, well, from 4 to 12, I'm adding 8. But if you check that, 12 plus 8 is not 36. So I must not be adding. Okay, can you do something else to make a sequence? Absolutely. You can add or add a negative, which is like subtracting, or you could even multiply. So we're not adding 8 every time. What else might we be doing? Well, 4 times 3 is 12, and look, 12 times 3 is 36, and 36 times 3 is 108. So that must mean that we are multiplying by 3 every time. So 108 times 3 is 324, and if I multiply that by 3, I get 972. And if I multiply that by 3, I get 2,916. Wow, okay, so with sequences that are multiplying, it looks like we can get big numbers pretty fast. So there are 2 kinds of sequences that we've just talked about. The first kind was an arithmetic sequence. I know that looks like the word arithmetic, but for some reason when it's an adjective, we pronounce it arithmetic. An arithmetic sequence is one that adds the same thing every time. And the thing that we're adding every time is called the common difference. So you can write this in your notes, put it in your composition notebook or something to help you remember. An arithmetic sequence adds the common difference each time. So let's look at 2 more just to practice. Let's find the common difference for this first arithmetic sequence. From negative 50 to negative 40, negative 30, negative 20, it looks like we're getting bigger by 10 every time. And so the common difference on this would be 10. That's what we're adding every time. Let's look at the next one. 21, 14, 7, 0. Okay, we're getting smaller, and it looks like we're subtracting 7 every time. So we don't really talk about subtracting, but we're going to say we're adding a negative 7. That's basically the same thing as subtracting, isn't it? So remember, arithmetic sequences are when you add or subtract, which is really adding a negative. So the second kind of sequence we're going to talk about is a geometric sequence. And that was the the one where we got the really big numbers because we are multiplying by something every time. And the thing that we multiply by every time is called a constant ratio. So you need to keep that straight, that the arithmetic sequence has a common difference and it adds. Geometric sequence has a constant ratio and it multiplies. Okay, write that in your notes, jot it down somewhere where you're not going to lose it. You're going to need to know that, this whole unit. So what are we multiplying by in this first sequence? We've got 1, then 5, then 25, then 125. Well, it kind of looks like I'm multiplying by 5 every time. And if I check it on all of them, it does work. So my constant ratio this time is 5. Okay, let's look at this one. I went from 72 to 36, and from 36 to 18, 18 to 9. Well, that one right there sounds like I'm dividing by 2, 9 to 4.5 sounds like I'm dividing by 2, but this says I have to be multiplying by something. Well, we don't really divide with sequences, we only multiply, but dividing by 2 is the same as multiplying by 1/2. So I could convert all of these to be multiplying by 1/2, multiplying by 1/2. So the constant ratio for this second one is 1/2. It's getting half as large every time. Okay, we like to describe sequences using formulas. And the first kind of formula we're going to talk about today, it's the only kind we're going to talk about today, but you'll learn a second kind in a couple days, is a recursive formula. A recursive formula has two parts, a starting point and directions. So this is important because you could have two sequences that are that have the same pattern, but they might start in different places. So for example, here's a sequence listed. Starts at 3 and it goes to 8, then 13, then 18, then 23. That looks like we're adding 5 every time. Okay, what if I started with a different number? What if I started with like -2 and I added 5? Then I would get 3 and then I would get 8. But wait a minute, that's a different sequence. Or, let's do a different one even. Let's say we start with 17 and I add 5. 17 plus 5 is 22, plus 5 is 27. So I'm adding 5 every time, but this red sequence looks a lot different than this brown one. Sorry about my cold. So that's why a recursive formula has to have two parts. It has to tell you where to start and what the pattern is. So let's go back to this one with a 3, 8, 13, 18, and 23. Where does it start? It starts at 3. And what does it do every time? Those are our directions. It adds 5 every time. Okay, well that's not so bad, but that's in English words, and what we want to do is actually convert this to being a mathematical formula. And so don't freak out. This isn't going to be too hard. You just have to memorize that this is what it looks like. When we want to describe the starting point in a recursive formula, we're going to use function notation. And so it's going to say f of 1. What that means is this function, and 1 is the first term. The first term is our beginning point. And so you're going to use that every time. So f of 1 equals 3. And on purpose, I'm using different colors here so you can see where the 3 came from. It started at 3, it started at 3. The first term was 3. Now, the next part that you have to memorize, this is what it looks like, the directions. It's taking the old term and it's doing the pattern to it every time. So it's kind of like we have the old term, then we have the pattern, and that's how we're getting the new term. To get the next term, you would take the old thing and do the pattern. So in function notation, this is what that's going to look like. And again, don't panic. This is something you can just memorize. Every recursive formula is going to have this stuff in it exactly the same. This is going to be the same, and this is going to be the same every time. You can memorize it and vomit it back up when you need to. Okay, so to finish our recursive formula, it adds 5 every time, so the pattern is that we are adding 5. So these two parts make up the recursive formula. You need both things. You have to tell it where to start, and you have to give it some directions. Let's do another one. This is actually on your classwork, so if you were absent and you wanted to fill in your classwork, this will help you. So on the classwork, we gave you this pattern of dots. It starts with 1 dot, and after 1 minute, there were 5 dots. And then after 2 minutes, there were 9. Sorry. And after 3 minutes, you're supposed to figure out how many dots there are going to be. Well, what's going on with this pattern? It starts at 1. And what's it adding every time? It adds 4 every time. Okay, so this time I used something slightly different in my recursive formula. I said f of 0 because in the beginning was before any time had started. So f of 0 is before time, at the very, very beginning. 0 time has elapsed. And that's where it's a 1. And then what's my pattern? It's adding 4 every time. So that's one way you could have written a recursive formula for 5a when it says write a recursive formula. And another way you could have written that, if you didn't want to start at 0 at the beginning, then you could have said f of 1 equals 5. And f of x equals f of x minus 1 plus 4. So do you see that it would actually be the same sequence if I started after 1 minute, or if I started at the very beginning? I will still generate these same numbers. I will still have 5, then 9, and then 13 would have been after 3 minutes. Okay, so this is going to get better, I promise. It's not going to be very hard to figure out this recursive formula. You do just have to memorize what it looks like and then what goes in the puzzle pieces. So on your classwork on the back, number 6 gives you a different looking sequence, and you're supposed to figure out what's happening. So at the very beginning, we had 1 dot, and then we had, after 1 minute, we had, okay, so I better not put the 1 dot. We started with 1, but after 1 minute, we had 3 dots. Then we had 9 dots, then we had 27, and then you have 81. So what's the pattern here? For number 6, you are multiplying by 3 each time. Okay, so if you can't see that, you kind of can go backwards and say, oh, 9 divided by 3 is 3, 27 divided by 3 is 3. Oh, I must be multiplying by 3 each time. Make sure you check it a few times in your sequence to make sure it works for everything so that you are getting the correct pattern, because sometimes they're tricky, and what you think is the pattern is actually not the pattern. Okay, number 9 says to write a recursive formula for the sequence at the top of this page. So I'm going to just start by writing down what parts of the recursive formula look the same every time. And I'm going to choose to start with 1 on this. To get my next term, I'm going to take the old term and do some kind of pattern. Now let's fill in what we know. We know that the first term is 3. Now, if you wanted to, you could have also said f of 0 is 1, and you're totally fine. That would be a great start to a recursive formula. You can choose. I don't care which term you start with, the 0 term or the 1 term. And then what was my pattern? I was multiplying by 3 each time. So I'm going to put a little times sign and a 3. I'd rather you not use an x right here because that can be kind of confusing since there is an x in the formula. So I like the dot to multiply by 3. That's my recursive formula. You could either have it like that, or you could have said f of 0 equals 1. You could have that for your recursive formula, or the top two. Just remember, every recursive formula needs 2 parts, a starting point and directions. Okay, here's your homework. So number 1 gives you a sequence, and you're supposed to figure out the next 3 terms in the sequence. 1, 2, 3. Let's find out the pattern. Looks like we are adding 2 every time. We're getting 2 bigger. So 61 plus 2 is 63, and then 65 and 67. Okay, that was easy enough. Let's do number 2. Again, you have to find the next 3 terms in the sequence, but oh, this is that tricky one where we're not adding 8 every time. At first you might think so, but when you check it, oh, 12 plus 8 is 20, not 36. So then what's my other choice? Maybe I'm multiplying by something. Well, 4 times 3 is 12, and 12 times 3 is 36. So that's the one where we are going to have to multiply. 108 by 3 is 324, and 324 times 3 is 972. And when I multiply that by 3, I get 2,916. Okay. Now, if you look down at number 5, it gives you the same sequence, but you're now supposed to write a recursive formula for the sequence. So same as number 1, same sequence as number 1. So the first term of that sequence, and how do I get the next term? I take the term before and I do some kind of pattern. That's what the recursive formula is telling you to do. So the first term is 55. That's all you do there. You just fill it in, 55. And then what were we doing every time? We were adding 2 every time. So the pattern is add 2. And you're finished. So let's look at number 6, the recursive formula. I'm filling in all the stuff that is the same every time. You just have to memorize this. This part's the no-brainer. A recursive formula will have these 2 parts every time. So let's go back now and figure out what was the first term of our sequence in number 2. Oh, looks like it was a 4. 4. And what was my pattern? Oh, I already found it. It was multiplying by 3, so I'm going to put multiply by 3. Done. Okay, so we will look at one more problem on the back of your homework, and that should be enough information to help you do the whole thing. We got a story problem here. You're supposed to first fill in the table, then write a recursive equation to describe the sequence. So we are building birdhouses, and I'm not going to do the whole table. I'll do enough to get you started. We want to know the number of birdhouses and the cost to build them. And this is if I build 1 birdhouse or 2 or 3, 4 or 5. And I know your table keeps going, so you can fill that in. So here's how it works. The business spends $600 to get started, and it costs you $5 to make each birdhouse. So even if I haven't made any birdhouses at all, I still had to spend $600. Maybe I had to buy a license. Maybe I had to buy some supplies. Maybe I had to buy some tools. That might be where the $600 came from. But if I build 1 birdhouse, it's going to cost me another $5 in materials. So the cost to build 1 birdhouse is the $600 plus the $5 it costs for 1 birdhouse. And then to build 2 birdhouses, it must be $610 because I'm adding $5 every time I build another birdhouse. Okay, does that make sense? So we can fill in by adding 5 in this table. And keep going on yours all the way to 7. Now let's write a recursive formula. I'm going to do 2. You can choose which one you like. You don't have to use both of them. I'm going to use one with the 0, and then I'll do it again with the first term over here, just in case you like that one better. Doesn't matter. You can choose either one. And later we'll talk about how you could even choose a different term altogether, and I'd probably still count it to be right. So the new stuff I'm going to write in green so that you can maybe see where things are coming from. So f of 0 is the 0 term, or the cost to make 0 birdhouses. That's not going to be 0. For this problem, it was $600. Remember, even if I didn't build any birdhouses at all, I still had spent $600 already. But then what would I do? To get the next term, I was taking the term before and just adding 5 every time. What was my pattern? I was adding 5 each time. Those are the directions. This is the starting point. These are the directions. Okay, let's do it again in case you just want to start with the first term, which in this case was 605. And again, our directions are still add 5 each time. So that part looks the same. So you can use either one of these. There's one recursive formula and there's a different one. If you like to start with a 0 term, that's great. If it makes sense to you to start with the first term, that's great also. Good luck with the rest of your arithmetic and geometric sequences.